Hello, everyone, and welcome to Chapter 8. So, we have learned now about hypothesis testing with the z-test. And so now we're going to give some additional information on what you can do beyond hypothesis testing. Because hypothesis testing is really only one way that we present information in psychological research. So, in this chapter, we're going to be talking about confidence intervals, effect size, and statistical power. So in this section, we're going to be focusing on confidence intervals. And the learning objective you should be walking away with is to be able to calculate a confidence interval by hand. So we'll learn what a confidence interval is, how you can calculate a confidence interval, and how confidence intervals are different from hypothesis testing. So first off, if we have a sample mean, which is known as a point estimate, we don't know for sure what the corresponding population mean is. Remember that our goal in research is to take information from a sample and then generalize it to a population. But samples are not always perfect representations of the populations that they come from. So sometimes a point estimate is not going to be the best way for us to get a good sense of what is going on in the population. But we do use them. Now, in addition to using point estimates, we can give an interval estimate. And one example of an interval estimate is a confidence interval to give us more information. So now instead of saying, I think that the population mean is this, we're saying, I think the population mean could be somewhere between this number and this number. Here is the range or interval that I think that the true population mean is. That gives us a little bit of wiggle room and really helps us to recognize that our guess is not perfect, that there is some error involved in our guess. All right, so let's take a look at an example. Let's say that we're looking at the number of texts people send per day. And we know that not everybody sends the same amount of texts, and that there is a sense of variability in the number of texts people send. And variability is how spread the scores are. And so one way that we have to look at how spread the scores are is standard deviation. And so the standard deviation is 9 text messages. So on average, people can vary by 9 standard deviations or 9 text messages from the mean. So we take a sample of 49 students, and they, over the 49 students, average sending 52 text messages per day. So we want to construct a 95% confidence interval for the average number of daily texts sent by students. So our goal is to guess how many text messages students send per day, and we're going to give an interval where we think that the real mean is somewhere in there. So, in terms of confidence intervals, we know that we can have a 95% confidence interval. That's pretty common. But there are other confidence intervals we can report as well. Sometimes people report a 90% confidence interval. Other times they report a 99% confidence interval. I've even seen 80% confidence intervals. It just really depends on how sure we want to be that the true population mean is somewhere in this interval or range. So your book outlines 5 steps that we have in order to compute a confidence interval by hand. The first is to draw a picture of the distribution that will include the confidence interval. So that's here. Now we're going to put in the information that we know as well. So we're building this confidence interval based on the sample that we've collected. And so the sample mean that we collected is 52 text messages per day. That's based on the 49 participants that we had gathered. Okay. And so we are developing this distribution based on the information that we know, which is from the sample. You'll notice that here I don't have mu, right? In other distributions that we had put together, I used mu, but we don't have mu. We're trying to guess mu here. And all I have to guess mu is my sample mean. So that's what we're using. All right, so now we want to indicate the bounds of confidence in the drawing. So I want to be 95% confident. So this is 95% here in the middle, which leaves 5% in my two tails. 5% in my two tails gives me 2.5% in each tail. Okay. So now step 3 is to determine the z-statistics that fall at each line marking the middle 95%. So remember that in our z-table, we can look at the tail or we can look at mean to z. So if I were to look at this percentage here from mean to z, it would be 95% divided by 2, which would be 47.5%. So I'm looking at 47.5% in mean to z or 2.5 in the tail in order to give me my z-scores. So let's take a look at the z-scores here. So I'm looking for 2.5% in the tail. Okay. That's here, and then 47.5% from mean to z. So my z-score is 1.96. Now, that should seem like a familiar number to you. We had 1.96 when we were doing a hypothesis test, but I want you to note that this is not the same thing as doing a hypothesis test. Okay, we are going to label our z-scores here. And here. All right, now we turn the z-statistics back into raw means, okay? So we use our z formula. All right, so we have that information there. Now, because this is a distribution of sample means, we have to make sure that we calculate the standard error. So for our standard error, we have our population standard deviation over the square root of n. So our population standard deviation was 9. Our sample size was 49. Right, so my standard error is 1.29. All right, so now I'm going to use this z formula to solve for mu, because that's what I don't know. That's my unknown. I know my z-scores, so I'm going to do the positive z-score here. My mu, or my sample mean, x bar, is 52. That was here. My mu is unknown over my standard error. All right, so I'm going to start by multiplying by standard error on both sides. That will cancel out. Now, I have a problem with negative unknowns. I have a really hard time with that. So I'm going to move my population mean to the other side so that it can be a positive mu. So that will cancel out. All right, so now I can subtract 2.53. All right, so one side of my confidence interval is going to be 49.47. Now let's do the other side. because I have a negative z value here. All right, so we're going to multiply by 1.29 on both sides. So remember, a negative times a positive is a negative number. I'm going to add mu to both sides. And that will mean I'll add. All right, and so the other end of my confidence interval is 54.53. So those are the 5 steps that your book outlines. So what does all this mean? Well, it means that we are 95% confident that the true average number of daily texts sent by students is between 49.47 and 54.53 messages per day. So that's my guess, right? And I'm pretty confident that the true mean for the population of students is somewhere between these two numbers. So that's what a confidence interval does. So let's compare confidence intervals with hypothesis tests. Remember, what is the goal of a hypothesis test? The goal is to see whether there's a significant difference between one population and another population. In this case, the population is students, and we have a sample of students that we had pulled. We want to see, is there a significant difference there? We assume that the null hypothesis is true, and we center our distribution of sample means on the population mean that we know, right? We know the population mean, and so we center our distribution on that, and then we calculate standard error. Confidence intervals are different. The goal of a confidence interval is to guess the population mean. That's not the goal of the hypothesis test. Hypothesis test is looking for a significant difference. The goal of a confidence interval is to find a guess for the population mean. We assume that our sample is going to be a good representation of the population. And we center our distribution on what we know, the information that we have access to. The information that we have access to is the sample mean. We're trying to guess the population mean. So this distribution of sample means is a little bit different. It's centered on the sample mean instead of the population mean. So they are different from each other. Do they have anything to do with one another? They are somewhat related, but you should be doing these analyses separately. So, for example, if my hypothesis test has an alpha level of 0.05, then my z critical values to set off the critical regions are going to be positive and negative 1.96. Now, that does not necessarily mean that your 95 or that your confidence interval is going to have the same critical regions. For example, let's say for the confidence interval, I want to look for a 90% confidence interval. If I'm looking for a 90% confidence interval, then I've got 5% in each tail, and my critical values are going to be 1.65 instead of 1.96. So these two are related, but they don't necessarily use the same z values. You have to make sure to calculate them separately. Okay. So let's go ahead and stop and practice, see if you can do it on your own. I'll give you a second to try and figure out the answer to this problem. Okay, so first thing first, we'll go ahead and draw the distribution. I know my sample mean. Let's go ahead and calculate standard error here. Okay, we want a 95% confidence interval. And so then this is 2.5%. And this is 47.5%. And then I need to find my z statistics, which we know from our table is 1.96. And then we want to turn the z statistics back into raw means by plugging them into my z-score formula. Remember that mu is unknown. That's the part that we're trying to figure out. All right, so this is one side of my interval, my confidence interval. All right, 12.59. Now, your book says step 5 is to check that the confidence interval makes sense. So first off, we know that the two means are surrounding the sample mean, right? Somewhere in the middle. And we want to make sure that the two population means that we have guessed are equally distant from the sample mean. So if we do 12.59 minus 12.2, we get a difference of 0.39. And then we want to do the same thing with 11.81. We get a difference of 0.39. So that interval makes sense. All right. So what do you want to take away from this section? Skills, be able to calculate a confidence interval given a problem, be able to write up the conclusion at the end of the confidence interval. So you have to know what this means. It's not just about getting the numbers, but being able to understand, well, what do these numbers actually mean? Big ideas here, understand what a confidence interval is, understand the difference between a confidence interval and a hypothesis test. And that's it for this section. I will see you in the next one where we're going to be talking about effect size. I'll see you over there. Bye.